All right, welcome back. So we were talking about the lunar eclipse and we were looking at it from a side view. Where's my mouse? There we go. So we can see the configuration of the three objects we've been talking about, the sun, the earth, and the moon. So what would you write down to help you understand what a lunar eclipse is? And again, the key I think is what is in the middle. So go ahead and jot that down. We'll pause now. Okay, welcome back. All right, moving on to tides, 22.12. All right, how does this figure down here help you understand? Man, I can't ever find my mouse. There it is. How does this figure down here help you understand tides? All right, so here's your Earth, here's your moon. You've got high tides. Looks like they're in line with the moon, doesn't it? And low tides looks like they are at 90 degrees to the moon. All right, so imagine you took a line and you drew a line to connect the two low tides, and then you took a line to connect the two high tides. Which line would the moon be on? So what determines the high tides? Write that down. All right, welcome back. And the last figure is wanting you to understand that not only does the water on Earth move because of the moon, but there's a diagram there that it's a little different than the one I've got. The one in your book has got a diagram and is showing red and blue with red representing a movement of the crust. I actually think this diagram works a little bit better. You can see the moon here, and the orange around the outside, that represents the Earth's crust. And you can see that the crust is being stretched out towards the moon. So does this figure help you understand what the Earth's crust does in relationship to the moon? So let's jot down what our understanding is of the Earth's crust movement because of its relationship to the moon. That's, again, what this section is all about. These three bodies, the Earth, Sun, and the moon, they have an effect on each other. So we'll pause here and you write down what the moon has, what effect does the moon have on the Earth's crust? All right, pause there. All right, welcome back. It's time to wrap this up. That was the last heading. So the next step is to read the section review questions on page 554 and jot down a guess to each one. Some of those you'll probably guess right, a couple of them you might guess wrong, but the idea is you look at that information and you write down your guesses so that when we go to the next step, as you read section 22C about the sun, earth, and the moon as a system, you are verifying or correcting those guesses that you took, all right? That will help you to read with purpose, and that gives you some structure to help you understand what you're reading instead of just reading it blind. That's why we do this pre-reading. It's very important. All right, and then the last step, there's a 3-minute video back on the link for this module, and it deals with the sidereal and synodic months. It's a real quick video, only a 3-minute video, but I think it will help you understand why there's two different ways that we can get these months, days, years with these two different methods. So when you watch that video, for credit for both of these videos, I want you to tell me why the synodic month is 2.2 days longer. Hint, it has something to do with the Earth. Submit your answer. You must watch the video before you answer that, or you will get it wrong. Now, if you think that you can just Google why is the synodic month 2.2 days longer, good luck with that. You're probably going to find something, but it probably won't match up with my video, and you're telling on yourself when you do that. I know the difference, and I am making a list of those who are just kind of going out and finding stuff on your own, because I think that's crazy. If you're going to spend the time and go look something up, go look up what I did. you're looking for something anyway, I've got the answer for you. Do the right thing. Thank you very much. We'll see you next time. God bless. Stay safe.